And welcome back to NCMAU. This problem can be found on page 222, and it is problem number 28. The key to this problem is that this size here is actually a diameter. So they're saying over here, sketch a mirror image. You don't have to actually sketch a mirror image. Just take and reduce these things by half. This one and this one by half, and that'll work to the right numbers. Anytime that you work an angle or a radius, what you always want to do is work to the tangent points. So we know that we have 313 thousandths radius here. We know that straight down it's going to be 313 thousandths from the center lines up and down. So let's go ahead and start to break this down into what we think will help us to solve for it by finding the angles. Okay, so this one's kind of simple. All we're going to do is use Pythagoras theorem on this. No use to use trig if you don't have to. Remember, Pythagoras theorem, or I should say a squared plus b squared equals c squared, is the basis for all trig. So here's what I've done. I know that I've got 313 thousandths from here to here. And I also know that I've got 313 thousandths from here to here. If I take this half of this thing here, half of the 7 inches, 98 thousandths divided into 2, say, and that would come up with this, 3 inches, 549 thousandths. That's distance from the center line, what would be the center line of this piece, up to the very top of this piece here, or I should say to the bottom of the ball. If I take that and I add, come over here, and I add the 313 thousandths to it, that tells me that the distance from the center line, which would be somewhere down around here, up to the very top of this is 3 inches, 862. So all I'm doing is taking the center line distance from here, from the center line of the part, up to the bottom of the ball, and adding 313 thousandths to it because that's what the radius is. So that comes up to 3 inches, 862. Then what I know is that I have a distance here of 7 inches, 336. I need to divide that into 2 because that's the diameter. And if I divide that into 2, that tells me that it is 3 inches, 668. Okay, that would be from the center line, what would be the center line, up to the very top of that. So what I can do is if I take the center line distance from here up to here, and I subtract it from the center line distance from here up to here, that tells me that this distance right here is 194 thousandths. So that's what I get here. So I took 3 inches, 862, minus 3 inches, 668. That tells me it's 194 thousandths. Now it becomes very simple. We know that we've got the hypotenuse of 313 because it's going to strike this radius all the way out to the very edge to where it breaks off. So that would be 313 thousandths there, and 194 thousandths here. So that means hypotenuse squared minus the side squared, or c squared minus b squared equals a squared. So I drew the angle up right here. And go ahead and sketch that out so you can kind of follow along with this. So here's what we're looking at. 313 thousandths is our hypotenuse, 194 thousandths is the other side. So if I go 0.313 and I hit the square key, minus 0.194 and I hit the square key, these are the numbers that I would come up with, but the bottom line is I would come up with 0.0603. Don't forget, we need to square root that, so that's why that square root is there. So when I square root 0.0603, I then come up with 245 6/10. Okay, now let me go through this one more time. 0.313, hit the square key. That would be the key that looks like this. Okay, that's that key there. Minus 194, and you can plug this in just the way that you have this. 0.313, hit that square key. Minus 0.194, hit the square key again, and then press the equal signs. If you looked at the LED readouts, you would see that 313 has a square of 97 9/10, and if you looked at the readouts, you would see that 194 has a square of 037 6/10. Okay, so this minus this gives you 60.0 3. Well, don't forget, we need to square root that. And that just tells you what these numbers are subtracted. Now you have to square root it because we've got c squared, which is that, minus b squared, which is that. But we haven't done anything for the a square yet, so I should put that down here so you kind of get the formula right. So this minus this equals this, okay? And that kind of gives you an idea. Now we gotta get to this. We've got to break it down to this. So we know then that a would equal the square root of 60.03. So that's going to be 245 and 6/10 when you hit that, when you hit the key that looks like that, or it looks like this. Okay. Now, we know that we've got 245 thousandths, 245 and 6/10 actually from here to here. That's what I've got sketched out over here for you. And you also know that you've got a center distance from the center of the ball over to the outside edge of 313. Okay, so from here out to there. So let's just take 313 minus 245 and 6/10, and guess what? There's your answer. 67 and 3/10 is the distance from here to here. Okay, all we did is we subtracted 313, which would have been all the way across, to the 245 and 6/10, which is the angle that we solved here. Tells us that we get an answer of 67 and 3/10. I hope that helped. If you have any questions, send me an email. Hope you're getting this pretty well, and we'll talk to you real soon.